All right, pre-calc, right now I want to help you walk through one of these problems in which we have to graph the ellipse and give the coordinates of its foci. You'll notice that we are not in a position where we can immediately graph it because the equation that we're given looks nothing like the form of the equation that we would like our ellipse to be in. So to get there, my strategy is going to be to complete the square for these two terms. So to start out, first I'm going to try completing the square for the x terms. Now I find it helpful to factor out this 4 first, so I can put this in a familiar form. 4 goes in, let's see, 56, that's going to be 1, 16, so let's have that be 14 times. And I'll put a blank right there. Similarly for the other term, I'll factor out this 9, get y squared minus, let's see, that'll be 9 times 8, 8y, then again plus blank. And I'll also move this 304 over to the other side of the equation. The reason I'm doing that is because I know that in our equation for our ellipse that we'll have all the constant terms on the same side of the equation, and that's opposite the side where we have our variable terms. So now that I know that we have x squared minus 14x plus something, I can see where that's headed. I can see that that is headed toward x minus something, all of that squared. Similarly, I'll end up with 9 times y minus something, all of that squared. Now, what's that something going to be? You might find yourself doing a little bit of guess and check here, but I find it helpful to think about splitting this term up into two pieces. Here, since that middle term is negative 14, I know that this constant term is going to be 7. So if my constant term is 7, then when I multiply that out later on, I'll have 49 as my constant term once it's all been multiplied out. By the same logic, I know that if this term right here is negative 8, then half of that is going to be 4. So I'll have a positive 16 when that perfect square binomial is factored or multiplied or FOILed out. Great. So altogether, this tells me that I've added on this side of the equation, I've added 16 times 9 to the equation. So to keep it balanced, I need to add 16 times 9 to the other side. The same thing is true for the 49 times 4. All right, 16 times 9, let's see, that's 90 plus 54, so that's 144. And 49 times 4, I'm going to do 50 times 4 in my head, 200, and then minus 4 again, so that should be 196. So now I'll just simplify a little bit. We'll have 4x minus 7 squared plus 9 y minus 4 squared. That's equal to 196 plus 4 is 200, plus another 100 is 300. So I think I can simplify this first. That'll be negative 4 plus 96 plus the 4, that was 200, so I'm left with 40. So altogether, that'll be 36 over here. And now to get this into our familiar form for the equation of the ellipse, I'll divide the entire equation by 36. This simplifies to be 4 over 36 here, plus 9 y minus 4 squared over 36 here is equal to 1. And then I'll just simplify these fractions. So altogether, we will end up with the quantity x minus 7 squared over 36, let's move that up a little, plus the quantity y minus 4 squared, oh, that's not 36. Simplifying that, that should be 9 there, and 4 here, that's all equal to 1. So what do we know now about this ellipse? Well, now we can see that this tells us that this larger side, so 9 is larger than 4, so a squared is equal to 9, or a is 3. And similarly here, this means that b squared is 4, or b is 2. That also means that c is going to be, well, let's see, c squared is going to be a squared minus b squared. So in the case of this ellipse, that'll be 9 minus 4, or 5. So c is equal to the square root of 5, slightly larger than 2. And now we can use this to graph out our ellipse. Now, as you know, I prefer to start without axes, so I will start with my center point, which I know to be at 7, 4. And then I will go over 3. So now I'll add an axis here. 1, 2, 3. To the point 4, 4. And then 1, 2, 3 over to the point 10, 4. That represents my major axis. I can add in my foci, which are slightly larger than 2. That will be my 2 foci. And then my minor axis has a length of 2. So I'll add that in now. 1, 2, up to the point 7, 6, and down to the point 7, 2. This gives me my ellipse. Now, if I wanted to get rid of those axes, I could. And I could add in the actual x and y axis, which would be a little bit below here and a little bit more over here. And that's where my ellipse would be in the coordinate plane. So, I hope you found this helpful. Going from an equation in a fully kind of multiplied out form over to the equation for the ellipse in standard form, which eventually gave us our graph.